In this video, we'll be looking at the library or manage color spaces options within ColourSpace. In the Manage Spaces library, we have all of our presets for color spaces, cameras if you have that option in your license, and the standard profiles, which are the 3 film emulation profiles. You've then got user color spaces, which are modified versions of the presets, as well as modified versions of the camera spaces, and obviously any profiles for displays that have actually been measured within ColourSpace. At the bottom we have various options for importing and exporting spaces and LUTs. We have display options for profiles, obviously delete and modify. Below that we have, for our LUT export, we have our options on the actual format of the LUT to be exported, as well as the likes of bit depth and resolution. So if we start with our color spaces, if we click on the name, we can just order them in alphabetical. And here we have, for example, the likes of Rec 709, sRGB, lower because it's a lowercase s, so it's at the bottom of the list. Interesting. BT1886, obviously the ST2084 options in the various gamuts. At the moment, obviously we interlink gamut and gamma. So for example, if we look at Rec 709, let's say, it only has the one preset, and if we actually look at that in a profile window, you can see that we have Rec 709 target gamut EOTF, but the EOTF, the gamma, there is no option. It's because at the minute they are linked together. So Rec 709 has a default of 2.4 gamma, and that is what that option gives us. But if we go back to our managed spaces, we can modify Rec 709, and we can choose to enter a different gamma, say 2.35, which was an option or a standard use some years ago, and we can save that with a new name, which is EOTF. This is actually a gamma because it's a power law, but EOTF is the correct terminology. And then we save that. That will now appear in our color spaces user. And if we wander down here, there we go, Rec 709 2.35 EOTF. Other color spaces have more options. So for example, HDR. So if we look at, say, ST2084 Rec 2020, when we select modify there, we have a number of new options based on the specifics of the ST2084 color space. So as before, we have the standard gamut values at the top for red, green and blue, and the white point. But this time we don't have an EOTF because it is fixed with PQ based HDR. This time we have a nits value, which is initially the standard 10,000 maximum nits for ST2084. But that can be modified to match any given display. So for example, if we have a display that has 1200 nits, that can be entered and then saved as a new color space with the new nits value. And if we call that 1200 nits, and if we go into our user color spaces, we now have 1200 nits preset. We can call back up, and then if necessary modify any other parameters and resave again. I mean, other parameters being the likes of soft roll off or tone mapping. If they're enabled, you can modify the values for the mastering display luminance levels, the start of the roll off in soft roll off, or for tone mapping you've got the mastering max and min, and the target max and the min. Obviously the roll off is a fixed algorithm. You can just choose the actual color space that the roll off is performed within. If you're matching this to an existing display that's been profiled, you can use target profile to select that. So for example, here we have, let's have a look, ACES HDR user 2. And if we select that, when we now enable, for example, soft roll-off, we can update the target max, nits and minimum from the profile selected. And that gives us a parameter to start from when we're looking to actually set what our roll-off is going to be. Same if we go into tone mapping, we can update the same parameters there, and you can see the effective nits updating to match that. As with any profile, once it's saved in the library, it can be used as a reference to compare to any display profile. So we open up a new Managed Spaces library, we'll go into our profiles, and we have here a ASUS 1200 nit verification profile. If we display that, we can compare it against our 1200 nit ColourSpace, and if we look at the EOTF, we can see how the display tracks relative to the PQ curve, targeting a clip of 1200 nits, but is actually clipping a bit lower, as once calibrated the peak has dropped to just over 1100 nits, and obviously we can see there's a little bit of a colour imbalance in the grayscale. We can also further modify the profile and include tone mapping. So let's make this 1200 nits. We'll use standard RGB as the ColourSpace to perform the tone mapping in, and we will call this tone map and save. And again, if we open up the same ColourSpace and display, we can now select our tone map, and when we look at the EOTF, we can now see the display profile relative to the same PQ curve, but with tone mapping applied. If we were to change that to, say, the default Rec 2020, oh, here we go, Rec 2020 10,000 nits, we can see that our display is obviously clipping at the 1100 nits relative to the full 10,000 nits of the ST2084 standard. In a similar way to PQ-based ST2084, HLG has some parameters that can be equally modified. HLG P3D65, and you can see here that we have a system gamma value for the HLG transfer characteristics, and if we modify the peak luminance values or the surround luminance, we can use calculate EOTF to modify the system gamma. So for example, if we say we have a display that is, oh, I don't know, 1500 nits, and if we hit calculate EOTF, you can see system gamma modifies. And if we say the surround luminance is 10 nits, and again calculate, you can see again it modifies. As before with PQ, we can use target profile to select a display profile. So if we use our HDR user 2 for ASUS, this was actually profiled using a power law gamma as the initial setting, so we can use this profile to make either a PQ based ColourSpace or indeed an HLG one. If we select that, and again we can see that the update this time, it gives us again our peak luminance, and we can recalculate the system gamma and obviously give it a new name and save it as a new ColourSpace as before. In a similar way to ColourSpaces, we can modify camera spaces, but we'll look at camera spaces in a different video that is dedicated to the camera options. Obviously, one of the prime uses of the managed ColourSpaces library is for display profiles, when displays have been measured and their characteristics recorded in a profile. Here we're not so much modifying a profile as using it to generate something different. So if we take, for example, this Chroma no probe matching 21 cube 3 profile and modify, we can extract from it a ColourSpace. So this actually generates a new user ColourSpace based on the primary RGB values and the gamma EOTF of this profile. So if we call this 21 Coupe 3 extract and hit the extract space, if we now go into our user color spaces, we have got a new matrix color space. If we hit modify, we can see that the red, green, blue primary and white point values and the EOTF have been extracted from the original profile. This means that we can use this to match the display to itself in a non-calibrated state. This is explained in the profiling video in more detail. We can also use what's called augment, which is the ability to combine two different profiles so that one profile augments the other. If we again look at the chroma profiles, we have here a chroma profile no probe match, but it's a very small 5 by 3 cube. That means that there aren't many measurements in the grayscale, but above it we have a chroma grayscale large with no probe matching, and we can effectively augment this profile by adding into it the grayscale. And you can see we've done that here because this profile shows that it has augment already applied. Now the process for doing that is to select the primary profile that we are going to augment, modify it, and then say that we are going to add to that augment data. And then from our list we can select our chroma grey large, no probe matching, and select, and that now has applied that augment data. And if we just call that aug new, so you can see it is a new profile, save that, and here we have our new profile with augmented data. When we then make a lookup table from this profile, it will use the additional grayscale data to generate a more accurate lookup table than you would otherwise have from the pure 5 cube profile on its own. The other prime function of the library obviously is to import color spaces, export them, import LUTs, export LUTs, and select a profile to display. So if we look at what we have here, first off we'll export an existing color space. So if we take our chroma, the one we've just done with our augment new, why not? And if we export that onto our desktop, and there it is, and we can open that with a text editor because it is just an XML file, which means we can actually see the values recorded by the probe originally. And if we run down, you can see at the point, here we go, that is the end of the initial profile data, and then this is where the augmented data added the additional grayscale information. And that means that we can use that in other programs as needed, and obviously we can choose to then load in, if we had modified that, back into the library using import space, and there is the color space we could reload had it been modified. Importing LUTs is pretty much the same. So we have on our desktop a film emulation LUT. We can load in. That now shows within the working LUTs part of the library. ColourSpace doesn't save LUTs internally. It only saves them while they are being worked on. If you close down ColourSpace, any LUTs in the working LUTs library will basically vanish. If we double click, we can open that to see it in the LUT generation part of ColourSpace, and obviously perform any functions that we wish with our LUT tools, etc. And then the changes will be saved back into our working LUT here. When importing a LUT, we have the option of importing a file format or our LUT image. For example, here we have a film emulation image, which again we can open and, as before, look at in the LUT side of ColourSpace. A LUT image is basically an image that has the LUT data encoded into the image, and that is from the LUT management, and we can export the LUT image from here as a TIFF image. The LUT image itself is exactly as it sounds. It is an image. If we actually open this up in a graphics program, you can see that the data is actually encoded into these two columns either side, and if we zoom right into those, then you can see that they are actually the LUT data as 3 by 3 pixel squares.